Good morning, everyone, and welcome back to another aquatic adventure. And I'm in a bit of a different spot today. I'm actually back at our offices because I am starting a science experiment today. The Greater Cincinnati STEM Collaborative has put out some incredible STEM cards, and there are loads of different activities on them. And today I have picked one that I think is going to be one of my favorites, and it's called Rainbow Celery. And so we're going to be talking about how water transports through different items. And so today what we're going to use is celery, because some of you may have it at home, but there's lots of other things you can use, and we're going to talk about that also. But the goal is, for us, is that we're going to set up a good science experiment. There's lots of things we need to consider when we set up a science experiment. So I'm going to walk you through some of the first things I've thought of. We're going to set up our experiment, and we're going to check back in on it later. So I've got a sort of data sheet here on my whiteboard that you guys can copy or make your own. But we start with a question. We always have to have a question in science. That's what it's all about. It's simply about asking questions and finding your own answers. So my question today is, how does water move through a plant? How does water move through a plant, right? Like, we have to drink it, we need straws. How do plants have that water move through their body? And we're going to see if we can see water move through their body because I have colored my water. So I have to make a claim. This is a hypothesis, a guess of what I think the answer is. I'm actually not going to give you my claim today because I want you all to make your own hypothesis and claim. But it starts with I think. So I have I think water, and how do you think it's going to move through the plant? Now, the way I'm going to test this is that I have 4 different stalks of celery and 4 different cups here. I have 2 that are red and 2 that are blue. I just did that because I wasn't sure if one would be more visible or easier to see, or if the color would impact it. We want to have a few different options to see what happens. And so with that, I have 2 of each. And the reason for that is that I'm going to put the celery in a different way. So I'm not sure if water collects on the leaves of plants and then travels down to the roots, or whether it is sucked up by the roots and heads up to the plants. So I figure if I put a stalk of celery in leaf first, that'll tell me one way. Or if I put it in root first, that'll tell me if it happens the other way. So I have 2 cups of water on each, and I am going to put the celery in both directions. Now, one good option could be to have a clear cup of water as well, but the one thing I do recognize is that I'm not going to be able to see that water if it's clear and inside the celery. So I decided not to have another cup, mainly because I'm out of space and out of celery. But if you want to do a clear cup, that would also be a great option. So it is about 8 o'clock in the morning. I'm going to put in my celery. I'm going to do, I have them listed here. So I have one that is blue from the leaf. When I have leaves, I'm going to do that one. So I'm going to do blue from the leaf. That's going to go in there. Hopefully it stays. I'm going to do blue from the root. So I'm going to put that one in this direction. I'm going to do red from the leaf. So I'm going to put that one in this direction. And I'm going to do red from the root. And I'm going to put that one in there. And so now I am going to come back. I have mine listed at 1 hour, 2 hours, 4 hours, and 6 hours. Again, mainly because of space on my whiteboard, but you can check at any intervals you'd like. Maybe you pass it every half hour in your house and you jot down a few notes of what it looks like, but that's going to be really important because we need to gather our evidence now. We've asked our question, we've made our hypothesis or our claim, and now we are going to start gathering evidence of what happens to this celery. And so I'm going to come back and track on my data sheet. I hope you all do the same, and we will check back in on these celery and see if we can understand how water travels through plants. Hello everyone, and welcome back to our rainbow celery experiment. It has been 8 hours since I set this experiment up, and I know I said I was going to check back at 1 hour, 2 hour, 4 hour, and 6 hours, but as I started, I realized that not a whole lot changed between 1 hour and 2 hour, so I've extended the time period a little bit. That's okay, that's science, right? We try things, we change them up when it's not working. So I've decided I checked back at 1 hour, 4 hours, and 8 hours, and I am going to leave this overnight, and I will probably post a picture or give you an update of our 24 hours and see if anything changes overnight. But let me tell you about our observations. This is when we are gathering our evidence for our science experiment. So I have mine written in blue so that you can at least tell it's a little bit different. I know you cannot read that. It's just notes for me. It's for me to tell you what all I see. So I hope you probably have seen something kind of similar, or you are expecting to see similar things. So I have moved the order of mine around here. The two I have together at this end, we put in leaves first into the water, and I put those together because they seemed to be acting more similar than the two red colors were acting similarly. So I have those together. On those ones, I really don't see much color change in anything other than parts of the celery that are touching the water. So the blue water and the red water have definitely moved up on the leaves that are touching water, but it really hasn't traveled through the stem and through this stalk at all. I don't see any red color throughout that. So we don't see any movement of the water here. On the other end, when we put the roots in first, we definitely see change. What you can see in our video now is that the color of these leaves are different. This one, the red cup, looks completely brown. Green plus red makes brown. So there is definitely red all the way up in all of these leaves. This one almost looks like a brighter green because that blue is really good with the green. But I do want to show you one other thing with my blue celery here. Actually, I'm going to move the camera so that I don't move the celery. So one thing you'll notice as you look in the cup is that the water is touching the celery there at a certain spot. But up above that, there's actually another line of blue. And now, I promise I did not bump these cups or move them in any way during the experiment, other than to change the order. And so that is evidence that water traveled up the stalk of celery, not to mention the fact that we see blue coloration throughout every leaf on our celery stalk. I'll show you the brown one too, see if that one's a little bit better. But the interesting thing that I noted in my first hour was that I actually noticed coloration in the very tips of the leaves first. And then the rest of the leaves started taking on that color. That's really interesting. But so now at 8 hours in these ones, color is all the way through the leaf, color is through the stem, and we can see evidence that water has come all the way to the top. So that's our evidence. That's what we observe with our eyes, what we notice during our experiment. Now we have one last step, and that is to understand our reasoning. Why do we think this happened? Why did water not travel up the celery from the leaves, but why did it travel up the celery from the roots? And this is actually because of capillary action. Now, a capillary is just a really, really narrow tube. Now, a straw is a good example of a capillary, but capillaries have to be way smaller than that because water droplets are really small. So think like a straw hollow, but like the size of your hair, even smaller than that sometimes. And so in a capillary, in that tube that small, water is actually able to travel the opposite direction of gravity. So that is how all plants get water to their leaves from their roots. They take the water in from the ground. As a water droplet evaporates from the leaves, a water droplet gets sucked up that capillary and travels all the way through the stem, all the way up to that leaf. And that's how capillary action moves. And now inside the stalk, what plants have is something called xylem. X-Y-L-E-M. And that is the capillary that water moves all the way up in that celery, or in any plant actually. And so what we can understand is that because of the properties of water and the properties of plants, this water was able to travel from the bottom of the roots of celery up to the leaves, but that's not how the leaf structure works. So there's nothing in a leaf that is able to take in the water and pass it throughout the rest of the plant. And so water does not travel down from the leaves of a plant. So we were able to see that during our experiment. Now there's lots of other things you could do this experiment with. It's really fun to do it with flowers, white flowers. You can make a white flower any color you want it to be if you put it in some colored water. So that could be a fun thing to do. You can also do this with paper towels. So that's another item that has really narrow tubes and the water is able to fill those capillaries and travel against gravity or up. So I encourage you to try this. Make more science experiments. I'm sure you guys have tons of questions out there. And just with our simple structure, asking a question, making a hypothesis, gathering some evidence, and then trying to make a reasoning. Why did that happen? You make a science experiment. I hope you guys let us know. Maybe post a picture of what your rainbow celery looks like, and I cannot wait to see it. Thanks. Hello everyone and welcome back for our final update on our rainbow celery experiment. It has now been 24 hours since I set all of our celery into these colored waters, and I'm coming back for one last update because I noticed something really exciting when I got back here to check on our rainbow celery this morning. And I'm gonna have to move these closer, so I'm hoping I don't slosh them around, because what I noticed was actually when I started this, I actually put a Sharpie line on my cup where I had filled the water to, and once the celery was in it. And so that would be so that I could see how much water the celery has taken up and if it takes up any water. We can tell, obviously, we've already talked about the color at the top of the leaves, so we know it took up some of the water because that color has transported all the way up with our capillary action all the way up to the leaves. But it's hard to tell just how much that is. And so what I'm going to show you here is where my Sharpie line is and how much water has been taken up. So you can see that there, which is perfect. So that Sharpie line right here is where the water started when I put the celery into the cup. And then look at how much water it sucked up. That is actually a lot. Last night when I left at 8 hours and we updated, it really wasn't even close to that. It had gone down a little bit underneath the black line, but it was not this dramatic. And I'll show you the red one as well. So you can see that both of the celeries, it is not about the color, but it is about the direction. I'm going to try and hold it nice and stable. It is about the direction that we have put the celery in. And so you can tell that there is definitely less water in each of these cups. And then I will show you our leaf one. I'll just do the blue one because I might drop these. They're a little bit more precarious. But this one, the water level has not changed at all. You can see my black line is right there, right where the water is. So really no water has been absorbed and transported throughout the celery when it is in leaf first. And that's because that's not how the transport systems work of plants. So I hope you guys have really learned lots about plants, their transport of water, and capillary action from your rainbow celery experiment. I hope to see pictures of your experiment and continue to check out the Greater Cincinnati STEM Collaborative Family STEM cards. And there is tons of other activities and science experiments just like this one.